I think what I'll do is I'll give a brief overview of the material that's going to be, you're going to be doing next time. I think there are, I believe there are 4 sections, 1.07, and then 2.01, 2.02, 2.03. And I think that I gave you 2 tries for each quiz. So let me ask you, because I don't know from my end, if you print out if you go into the quiz, do you have to finish it? Or can you go out again and submit after?
When I went to see you earlier today, I had the quiz up.
Yes.
And I guess it timed out and logged me out of Canvas. So it let me go back in.
It let you go back in.
That as an attempt, but I didn't actually exit it myself.
It didn't? Well, okay. Well, if it let you log back in and you didn't submit, then most likely you can do that. So you don't have to complete in one sitting.
Yeah, because I was using a different browser, and some of the questions weren't even popping up, so I exited out of it.
Right.
Chrome.
And it didn't count that as an attempt?
Mm-hmm.
All right. So then you can use that information. You don't have to finish the quiz. You can do something and then go out and then finish it. So as long as you don't submit, it doesn't count it as a submission.
So do one question, go out to eat, and then
Yes. Yes.
Probably not
go for a
beneficial
walk.
for us, but I think
Yeah.
1.07, when I first entered there, it said unlimited submissions.
Really? All right. Well, we have to fix that.
Yeah, one of them did anyway.
Okay. We certainly have to fix that. Okay. All right. So let's see. Okay. Let's see. So we'll go here. Now, I think that some of these things you probably saw at one point in your life way back.
way back when.
Yeah, way back when. So this is the Taylor series. And Taylor series really is, it's a beautiful subject and also an important subject. So I do recommend you look at the chapter. So let's go there. And so I think he goes through the theory of Taylor series. He shows how to find it in terms here's the formula in terms of derivatives. And with the idea about Taylor series is that in order to find a function at any point whatsoever, all you need to know are the derivatives at one particular point. If you know all, then that's quite an incredible thing, isn't it? That you know all the derivatives at one particular point, and that allows you to find the function wherever. Now, that's not true for any function, but it's true for a large class of functions. It's true for a large class of functions. So it's really quite incredible.
What's his name? Dr. Baum, I forget his name, that does did the textbook and the videos. He talks about the fine print of between X and H. It must be continuous.
Yes.
Yes.
Yeah. Right. So go through here. So he shows this. Now, I think that sometimes they use the X and the H. Sometimes they use different notation. I think they may use A and X. If you use, so let me see here. If you write this, here's one way to write it. So let me pull up another page here. And another way to write this would be I want this. Sorry. Screen clipping. So here's one way to write it. And that's a common way of writing it. Okay. Another way to write it would be something like this. F of x equals f of a plus x minus a times f prime of a plus x minus a squared over 2 times f double prime of a plus, and so on. Now, do you see that these two things are really the same thing? All right. So this is an equivalent This is an equivalent. So the two are equivalent. Okay. So in this case, your x in this. So I can make a table here to make the correspondence. So this is the first expression, and then here's the second expression. In the first expression, you have f of x plus h, right? So x plus h in the first expression corresponds to x in the second expression. You see they're in the same position. X in the first expression corresponds to a in the second expression. And h in the first expression corresponds to what in the second expression? You tell me.
Oh, x minus a.
It's you can see if you look at this carefully. Here's a x minus a here. Here, let me turn this on. Sorry. Do I still have this? Yeah. Let me turn this on so you can see my. Okay. Let me make this a little bit darker so you can see what's going on. Is it there? For some reason, it's not showing my because I know that the pointer is too small to see. So, sorry. Let me just set this up. Give me a second here. I'm going to exit, and this is called If it's not going to work, it's not going to work, but let's see if I can make this work. All right, there we go. Okay, so now you can see my cursor a little bit better. But it's, there we go. All right, so what was I talking about? Well, I was saying that if you look at this expression here, you have several terms, and you have powers. Here you have powers of h, and here you have powers of x minus a squared. So this is x minus a. Right. But the point is, if I want to draw a picture, and here I have, for instance, if I have a function that looks like this, okay. And suppose this is the point where I'm evaluating the derivatives. And then here's the point where I want to evaluate the function. All right, the point is that you've got these 2 points. You have one point where you're evaluating the derivatives, one point where you're evaluating the function. Now, in the first case, the point where you're evaluating the derivatives is x. In the second case, the point where you're evaluating the derivatives is a. Right, so I could label this as this is x slash a, right? Now this point here is where you're evaluating the function. In the first case, that's going to be x plus h, and in the second case, that's what you call x. So this is going to be either x plus h. And by the way, you don't. I will make these notes available, so you don't need to copy. And then this distance here, this is the distance between the 2 points. This is in the first. That's called h. So this is you can call this the separation. And the separation is h in the first way of speaking, and in the second way it's x minus a. So you can say that the first way of writing the equation is focusing on the starting point and the difference. So you're starting at x, and h is your difference to the new point. Mm-hmm. The second way is focusing on two different points. You have the point where you're evaluating the derivatives and the point where you're evaluating the function. So it's just the same thing from a different point of view. But so you need to keep things straight when you're looking at equations. All right? I think it's always helpful to draw a picture so that you know what you're doing. But again, there are 2 points involved, and you're trying to use the derivatives at one point to find the function at another point. So that's kind of how you can think about it. All right, so if we scroll down through here, and here's just calculation. I do also strongly recommend that you do your quizzes in Excel or Python. Probably I should encourage you to use Python. Because if you make a mistake, you go back and change your code, and you don't have to redo you don't have to redo everything. So I strongly recommend that you start doing that.
And in Python, you don't have to go click on a cell to see what you
Yeah,
actually
yeah.
did in
I
the
mean,
cell.
yeah, Python. I mean, there's a lot of, and it'll also help you get used to using Python, which I think is another good advantage. All right. All right. Now there's also an expression for error, because of course, whenever you have a numerical approximation to something, there's going to be error, and there's an expression for the error, which depends. So if I take this expression and I take here I actually have n plus 1 terms, right? I have, because I'm starting with this has a h to the 0, h to the 1, blah 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 up to h to the n. So I have n plus 1 terms here. If I have n plus 1 terms, there is an error, and the error depends on the nth plus 1 derivative at some unknown point. Now, this unknown point is the point between the point where you evaluate the derivatives and the point where you are finding the function. All right, so here's a formula for error. And if you want to estimate the error, you just need to know, well, about how big this n plus first derivative is. So he'll give some examples about that. Okay. So and you can read the details here. But by the way, just to make sure that you know about this, you also have as a resource this. I think people know about this. I shouldn't be showing this. Here we are. If I go home, if you go to the course guide, you'll find all of the equations that you need, and kind of a summary also of the concepts. Oops. Right here. So if I go here and I look for Taylor, well, it's not going to let me. I'll just do enable editing here. All right. So I think it's good for, after you've gone through the material, it's good for you to look here and see what you're expected to know. Now, why did it go back? Okay. Okay. So you can see some concepts here. Okay. And these are the things that you're expected to know. All right, so I do think it's good to, once you've gone through the textbook, look at this, and then I think it's also very valuable to take the here. Let's go back. All right. I generally look at the textbook. I think the videos are also pretty good, so you can. Look at that, but by all means take the multiple choice test. By all means do that, and then he also gives detailed answers at the bottom. So I hope you know about that. If you go down here, he gives a complete solution. So, and we designed the quiz problems to be similar to these. So really, this is your best preparation. If you go through, and don't just look at it and then read the answers, and try to get the right answer, okay? Because that's how you really learn how to do stuff. So that's a Taylor series, and then you'll take the quiz on Canvas. All right. So let me go back here. Then I think the next three sections are more on derivatives, and the basic idea of derivative is a ratio of differences. All right. So rather than going through each of these in turn, let me just go through the summary. The summary is down here. So this is kind of calculus rundown. I think these terms should be familiar to you. Chain rule, product rule, quotient rule. Fortunately, I don't ask you to prove these. So this 2.01 is just a primer. So this is calculus stuff. There's really no numerical. There's no numerical here. This is all just from calculus. So I'll pass through that. All right, then here we start talking about numerical. There are different ways of approximating derivative. Something called forward difference, backward difference, and center difference. And they give different results. And some are more accurate than others. And you have error terms for them. And then here's something you may not know. And of course, in physics, you have velocity, which is speed, then you have acceleration, which is how you're speeding up, and then the third derivative is called jerk. So, and that's actually a technical term. All right. So,
who came up with that?
well, but it actually makes sense.
Yeah.
Because that's what when you feel a jerk, what's happening? You weren't accelerating, and then suddenly you accelerate. That's when you feel a jerk. So jerk is a very appropriate term. All right. So these are the three different differences, and this also you may see differently. So let me copy this also. I'll just go here. So let me start a new page. And whoops, that's not where I wanted to go. Okay.